uncertainty factors that you should considering?
Yes, there is a list, and there are specific ones that are considered. There are usually 5 of them that are held up, and they take a value between 1 and 10.
Yeah.
And one of the things we found, for example, there's an uncertainty factor that is called the database uncertainty factor, and it's intended to reflect a situation in which perhaps a chemical hasn't been tested as well as you might like, or there might be concern that there's an endpoint out there that could still be of concern. We found the US EPA applies that way more to the same body of data than other organizations do. So that right there will often add a factor of 3 or a factor of 10 difference to reference value based on their choice of how to handle that one specific uncertainty factor.
So you talked a lot about animal testing and traditional tox studies. I wanted to know what your opinions are on like high throughput in vitro data. I know that the EPA announced phasing out of animal testing. So what are your thoughts on this sort of in vitro data, its usefulness in decision making?
It's going to be the next thing in 5 years for. No, how do you say that? Like that it's always going to be the next big thing, and it's taken 20 years, and we're still not ready to make decisions with data that come from tests that are done on cells or even I hope it gets there.
Question? Yeah.
Here.
Oh, okay, so you said with the more rapid assessments are looking more at like a reference value and less of what actual outcomes will occur after. So I'm thinking of something like prednisone, which is not a chemical but a pharmaceutical where you have different outcomes and also people are prescribed it for a different amount of time. Like I've been given it for a super sore throat where my throat was about to close up, so I was given it, and then cancer patients are given it as an anti-inflammatory, and they have different outcomes. So.
Well, so one of the things here is that there's a difference between things where we have very good human data, and we've sort of seen it play out, and situations in which we're dealing with much less certain animal models for people. So I think that you would want to consider something about the levels of exposure. I mentioned, I didn't talk much about it, but the levels of exposure can be pretty important. That was the difference with that substitute for perchloroethylene, in that you would actually have more exposure to it if you used it in the same way because of its chemical properties. So you've got to think about exposure, and it might be that for some things there are different kind of levels or durations of exposure that you would want to consider. Part of what you're also talking about, though, is sort of a conditions of use. You're much more willing to take on a chance of an adverse outcome or a bad side effect when you're treating a really serious disease like cancer than when you're doing something else, right? So that goes back to the context of the question that you're asking.
So you talked about the 40,000 chemicals that are already out. What's the process? So I'm a big chemical company, and I want to introduce a new chemical for some industrial process. So it's not going to be added to food. It's not going to be used for makeup or cosmetics or whatever. What's done? How do I
So
introduce
new chemicals have to go through a process at EPA called, if you've got something and you're going to make it, you have to file a pre-manufacturing notice, a PMN. So this is our chemical regulation treats basically chemicals that were on the market before 1976 differently from everything going forward. So if you're making a new one today, you have to come forward to EPA, say, here's what I know about this chemical, here's how it's going to be used, it's going to be in food or it's not going to be in food, it's going to be a chemical intermediate only in some kind of closed vessel, and you tell them about the use, and any toxicologic information you have. Interestingly, it used to be EPA had 90 days, and if they didn't make a decision, go ahead and make your stuff. The changes to the chemical management law now say EPA has to make an affirmative decision. They actually have to say, if you use this, it shouldn't be a problem. And that's really changed things. So they actually changed what they call the burden of proof. And they now need an affirmative finding. So now you bring this forward, EPA looks at the data, they can both call in, they can ask you for more data, they can deny your pre-manufacturing notice and you can't make this stuff, or they say, we believe that under the conditions that you described, this is fine. So that's new chemicals. Old chemicals, though, are a very significant part of that 40,000, but it's not all of them. Yeah.
I was just wondering how often they get denied.
Boy, I just don't know. Because a lot of that also happens in a way that, often if somebody has invented a new chemical, they consider that confidential business information. They don't want the structure getting out, because they think they've got something that's going to be great and all of these things. So a lot of that happens in a way that's hard to get that kind of information. Yeah, just,
Sorry, I just have a question about the high throughput thing.
yeah.
And they're phasing out animal testing. So that's what, isn't high throughput dependent on data? Like if I'm coming from a computer science background, data drives high throughput. It cannot invent data, right? So where's the data coming from then? If it's so few chemicals have been tested.
So for those of you who don't know, there are new methods that are being used in toxicology that are testing chemicals rather than in a whole animal. They're testing it in isolated cells or even with isolated macromolecules, with proteins, with receptors, with DNA. And the idea is that if you can find a biological interaction there, it tells you about something, what adverse effect a chemical might have. It's exactly right that the way those models work is that you compare, you look at how a chemical that you know its effects on animals, how it looks in your high throughput test, right? You have to, it's like artificial, anything, you gotta have a training set of data for that. So that's when I was in EPA, we actually had a really cool agreement that we made with FDA and pharmaceutical companies to get data on failed pharmaceuticals where they had not made it through the safety, the toxicity testing, so that we had data that we could put into some of these high throughput kinds of screens. We also took the data from every single pesticide. Remember, they have all that data? So every neurotox test had been done on every pesticide. They were taken out of boxes. They were literally, these studies were in paper boxes and put into a database. It's actually publicly available if you want to look at it. But that allowed training of some of these tests. These tests still aren't doing that well. And part of it is we don't know, if you're looking for cancer, we test chemicals for cancer in male and female mice and rats. Which ones do we call carcinogens? Does it have to cause cancer in just one of them? Two of them? All four? So there's still even the data that you think you're putting in has judgments and choices that can influence how well your thing performs. So, but these are all trained on data, so they're limited by the world of chemicals that have been tested. Two, we get Ralph and then Ron, and then we got.
So the United States isn't the only country developing new chemicals or doing these analyses. How much information transfer is there between countries?
There is some, and a lot of chemical companies are global multinationals. But there is some, so the chemical management law in Europe is called REACH, Registration, Evaluation, and Authorization of Chemicals. They made it into a nice acronym. There are some of these confidential business information arguments that prevent some of the sharing of data. And also, companies over there are paying a whole bunch of money to test things, and they don't want to just give that money to their competitors who might be making the same chemical. So there's a lot of work trying to make more harmonization or sharing of data, but it's not as good as one might hope. An awful lot is what's available in the open literature. That is available. Ron, you get the last question.
Okay. Waste of.
Did you think your talk was reassuring or appalling? I'm just really, I mean, are there any studies that look at the differences in value? I mean, the discrepancies that you showed are
Yeah.
remarkable, so let's focus on Canada and EPA, 7% concordance.
There's absolutely no evidence that people in Canada or in the
Are
US
less
are
healthy
any,
or more
more or less healthy.
None.
That's
So
correct.
what does it all mean?
You know, that's, oh man, now you're gonna keep me up at night. No, it's a great question.
There's a department of existentialism, you know.
Yeah, no, this, it may well be that the way we do things is, you know, in some ways sufficiently conservative all the way through it, that a difference of tenfold still doesn't matter. You can be safe or you can be super safe.
We don't know.
Right, but at some level, we want to believe we've got some way of counting, you know, there are enormous ranges in toxicity in chemicals, whether you're looking at acute or chronic toxicity, levels of exposure to cause harm. Somehow we want to be able to take that into account when we're comparing alternatives for specific functions. And so I still think we need some way to do it. Maybe we're not very good at predicting what's actually going to happen or who might get sick, but we can predict the relative toxicity of materials in a way to have less potential risk to people by doing more of that.
So is it the difference between cigarette smoking and, let's say, a sugar substitute, where one is very obvious and the other?
Yeah, no, it's much like that. You know, these are probably, if they're happening, very subtle facts. You know, and if we're managing chemicals well, and again, if we're looking at, you know, a lot of the Western world, we probably are. There are probably places where we might not be doing that nearly so well. It may well be that this is a very, you know, a small part of the noise. Wow, well on that.